Hello, everyone, and welcome to this NESP Climate Systems Hub webinar on drying out, looking at the summer ahead and beyond. For those of you I haven't met, my name is Ramona Dalla Pozza, and I'm the knowledge broker for the National Environmental Science Program, NESP Climate Systems Hub. As you can tell, a bit of a mouthful, so we often just say NESP Climate Systems Hub, or we might refer to it as just the hub, and that's hopefully you'll all know what we're talking about at this webinar. I'm based at one of the hub partners, the University of Tasmania, but actually physically based in Melbourne. In today's session, we'll be talking about how Australia can quickly flip from wet conditions that we've experienced over the last few years, and then can rapidly dry out. And then, as we have already seen this year, it can coincide with extreme heat and bushfires that I know a lot of you in Queensland and other areas have been experiencing lately. So Australia is definitely a country of extremes. I'll introduce our speaker in a moment, but first I would like to acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the custodian of Melbourne, where myself and the speaker Ailie Gallant are joining from. We pay our respects to the elders past, present and emerging, and would also like to extend respects to all Aboriginal and Torres Strait Islanders joining us today. We recognise the important role that traditional owners play in understanding Australia's climate, and we know that a lot of you are dialing in from across Australia, so thank you very much for joining and supporting us today. But we'd like you to take a moment, please, to acknowledge the traditional owners of the country where you are joining from. I'll also go through a few housekeeping things. So before we move on, please ensure your microphone is muted. This workshop is being recorded, and we'll be able to send you the link for that recording afterwards, and it'll also be available on the NESP Climate Systems Hub website. We do encourage you to ask questions. This can be done at any time by typing into the Q&A function that you can see at the bottom of your screen. I encourage you to do that early. We don't always have time to address all the questions, but we'll do our very best to do that. And we will have a formal Q&A session later after we've heard from our speaker. And we are really keen in this session to hear from you. So we'll actually be asking you questions. So it'll be a bit of an interactive webinar today, maybe a bit different to what you've had previously, where we'll be asking you questions and they'll pop up on your screen at different points throughout the session. And we really, really would value your feedback. Just a bit about the NESP Climate Systems Hub webinar and workshop series. I'm part of the knowledge broking team, as I mentioned, and we as the knowledge brokers are really trying to encourage, and the communications team as well, trying to encourage participation and interaction with our users through workshops and webinars. We welcome, if this is the first one of these webinars that you've come to, these webinars are really designed to provide an opportunity for learning and interaction, as I said, with a broad range of topics and experts. We're really interested in your perspectives, so please do participate. And we'll be, as we said before, we'll be asking you questions throughout the session, so we really would like your feedback. So please let us know what you think and how this is meaningful to you. And also afterwards, we'll ask for the evaluation, so we really value your feedback on that as well. So without any further delay, I would like to warmly welcome our speaker today, Associate Professor Ailie Gallant. Ailie is an Associate Professor based at the School of Earth, Atmosphere, Environment in the Faculty of Science at Monash University. Her research interests really focus on drought and precipitation variability and precipitation extremes. And today, Ailie is going to speak to us about her work in the Climate Systems Hub, and within the project, the broader project, extreme climate, dry, wet, hot and dry, looking at recent events around Australia, where she will examine the implications of the rapid drying trend, as we mentioned, on the upcoming summer and summers beyond. And I'd just like to say that when, we all have different understandings of drought, and the word drought, in a government context can be related to, drought declarations. So just so that we're all aware that we're not really talking about drought declarations here, but Ailie will make it really clear what she's talking about. And we're really excited to hear about this new research that she's working on. So thank you, Ailie. Please, we'd really like to hear from you now. Thanks.
Thanks very much, Ramona. I'll just check you can hear me okay. Yes. Fantastic. Okay. Thanks, Ramona, and thanks for coming along, everybody. It's so great to see everybody here. As Ramona said, I'm a climate scientist. I'm at Monash University, and I also just want to acknowledge my colleague, Dr. Pallavi Goswami here, who's helping me undertake a lot of this research. I should also say, as Ramona said, this is something that we're just starting to ramp up here at the Nest, this research. And so it's still very much ongoing. So some of the stuff I'm going to be talking about today really would value your input and your feedback around what we're looking at. So here we go. Okay, so let's start with a bit of context around what we mean when we're talking about drying and rapid drying. And nature likes to throw up some interesting case studies for us on occasion. And, going from the last 3 years of triple La Niña and very wet conditions into what is shaping up now to be a very dry 2023 certainly makes for something interesting for us all to think about. And so really one of the questions that we're asking here at the Hub is around how do we get from the left-hand panel where the blue colors show, quite high rainfall, very much above average, highest on record rainfall for kind of late winter and spring last year, to the panel on the right, which is very dry conditions that we've seen. And this is just precipitation, but thinking about the fact that precipitation has been very much below average for the last few months, even throughout the winter at this time this year, right? So this is just a year apart. How do we get from that wet to that dry? It's one of the questions that we're really asking. And so we can kind of think about this as climate flip-flops, right? And we're very familiar with climate flip-flops here in this country, from droughts to flooding rains and back again. But how does this transition actually happen? And in particular, some of the drying that we're seeing, anecdotally, people talk about it coming on very quickly. Did the drying come from nowhere? And so before I showed you precipitation, and here and throughout this talk, I'm going to be talking about soil moisture a lot. As Ramona said, most of the time throughout this talk, I'm certainly not talking about areas that might have been officially drought declared from a government standpoint. I'm going to be talking about drying and drought from a climate and landscape standpoint. So here I'm talking about soil moisture, and I'm talking about something called root zone soil moisture, which is about, this is approximated as the water available in the top 1 meter of soil. So again, thinking about from last year to this year, this is just October last year to October this year. So last year, 2022 is on the left, October 2023 is on the right. And you can see the blue colors on the left indicate much wetter than normal conditions. And of course, the red colors across much of Australia that we're seeing now indicate much drier than normal conditions. So how did we get there? And did this drying come from nowhere? That is one of the questions that we're thinking about. And so more broadly, we're thinking about transitions. We're thinking about transitions toward drought-like conditions at the surface. And so some of the questions that my team is asking within the Hub and within one of the projects within the Hub is thinking about how rapidly the landscape can move into drought conditions and how quickly those conditions can change. We're also asking questions around what causes the landscape to dry in the first place and to dry quickly. It's not just about drying, it's about drying quickly. And also, what are the implications from rapid drying in 2023? As a climate scientist, I think this year and the transition from 2022 to 2023 is quite interesting. But maybe there's implications for you in the sector that you work at. And yeah, so 2023 is a period of time that we're also focusing on. So what do we mean by rapid drying and intensification for drought? Let's take a step back from thinking about this year and let's move into thinking more conceptually about rapid drying, right? So rapid drying and intensification to drought really is an emerging research area, and it's something I've been working on for a couple of years, but it's something that has people have taken note of and scientists have taken note of around the world, probably in the last 5 to 10 years. And most of this research has been around a term called flash drought, and I'll define what that means in just a minute. But typically when we talk about rapid drying and intensification into drought, and when that happens quickly, what we're talking about is summed up in this diagram here. So this schematic is really showing how this happens. So if you think about moving in time from the left to the right of the panel, we think about periods where we might, we've got normal kind of soil moisture, things are all going hunky-dory. Then all of a sudden, a weather system sets in where we have no precipitation or very little precipitation, nothing of any appreciable consequence, and that cuts off the moisture supply to the soil. As hot weather sets in, it's warm at the surface, we have prolonged periods with very clear skies, and the atmosphere, consequently, we usually have a dry atmosphere. It starts to become, as we say, the atmosphere becomes more thirsty. It has high evaporative demand, right? And so that then means that the landscape can start to dry out and dry out quite quickly. So soil moisture then depletes rapidly because we've got enhanced evaporation, and we transition on the right there into quite dry conditions quite quickly. So that's what we're thinking about when we're thinking about rapid drying. And as I said, one of the focus areas for research in the last few years, and something that my team has been working on a little bit, is around this term called flash drought. Okay, so flash drought, you might have heard of the term flash flood before, but if you haven't heard of flash drought, it largely thinks about the same thing. So this is a drought that can come on quickly. We're talking, typically definitions vary, but we're talking about a drought that moves from near normal conditions. When I say conditions, I'm talking about soil moisture conditions, for example. So near normal soil moisture conditions to drought-like conditions, very dry conditions, within around 1 month or less. But flash drought has also more recently been described too as a bit of an intensification of drought. So we can go from near normal conditions to very dry conditions, but we can also have rapid intensifications within a period of drying. And that's a period where, droughts can drying can seemingly rapidly intensify. And I'll show you later, we might argue that September and October this year has been one of those periods. So basically what's shown on the right hand plot here, let's get to the plot. So the map here shows, all I want you to take from this is the redder the color, the redder the color, the more frequent we've had periods where we have this rapid drying. So in other words, this kind of shows periods where rapid drying is perhaps more common. So you can see hotspots in central eastern Australia, in parts of southern Australia, and all in parts of southwest Western Australia and parts of northern Australia as well. Those areas where it's more yellow and white tend to experience fewer periods of very rapid drying. I can go into the definitions of this later if anybody wants to know specifically what we're talking about here, but the takeaway is that these things happen across Australia, but where they happen more frequently can be a little bit different. And that's kind of, at least in climate science circles, that's kind of thinking about flash drought is a little different to how we've thought about drought previously, because of course, drought means different things to different people. I'm sure if I asked every single one of you in this virtual room what a drought was, every one of you would come back with a different answer. So drought is quite a nebulous term, but when we're thinking about drought, most of the time, most people kind of think about drought and drying as very slow moving, right? I think it's been described as the creeping phenomena. So, you know, unlike a lot of other hazards that we deal with that kind of happen quickly and come out of nowhere, droughts usually take a while to develop. They can progress over the course of months, and you kind of see it drying out a little bit through 1 month, 2 months, 3 months, and then, you know, a few months later you realize, yes, okay, we're in drought conditions. Flash drought, on the other hand, is at the very quick end of the spectrum. So if we think of drought as a spectrum, which is kind of what's trying to be displayed in this plot here, and in this plot, we've got kind of spatial scales on the left, on the y-axis and on the vertical axis, and we've got time scales on the horizontal axis here. Flash drought can be considered, you know, in that spectrum of drought where the time scales are very quick. Typically associated with that, the spatial scales are often smaller, though not necessarily. But it's really part of that broad spectrum. So the nature of flash drought is such, what really defines it, as I said before, is its rapid onset. And so this is what we're looking at the moment. So flash droughts, as I said before, the locations of them, they're more frequent in some areas than others. But flash droughts can also be flashy because they don't last a long period of time as well. So our work in the previous iteration of the National Environmental Science Program showed that flash droughts typically last around 40 to 60 days. That's about the average. So a month to 2 months long. So you get this period of rapid drying, descent into very, very dry conditions. So when I say very dry conditions, we're talking, for example, soil moisture in the lowest 10 or 20% on record. And that period of very dry conditions lasts for around 40 to 60 days. Though that's not always the case. We did observe some of the flash droughts that we defined in this paper that you can see down the bottom here, Parker et al. 2021. We did find that some flash droughts tend to last longer than that. So we saw a couple, for example, in the Wimmera region of Western Victoria that lasted upwards of 3 months, and 1 or 2 that lasted for 6 months. So in that sense, flash droughts aren't necessarily flashy in that they don't flash on and off, but they can flash on quickly, but then kind of descend into a much longer term drought as well. So when we're thinking about rapid drying, thinking of periods of intensification of drought and thinking about how that affects different locations around the country and what the impacts are for that, we'd actually love to hear from you all about how rapid drying affects locations where you are or where you work. So up on your screen now, you should see a poll. And so there's 2 questions associated with this poll around how does rapid drying affect your location. First of all, if you could tick any one of those or multiple choices there. There is a choice for other, and if you have other, please do elaborate on that in the second question. Also, would love to hear if anybody would like to put in the chat or the Q&A, or even put up your hand, and I think maybe we can unmute you to ask a question. We'd love to get feedback from you. We'd love to get feedback from everybody about how rapid drying's affected your location. But I'll give you a minute to fill that out now, and we'll come back to the talk in a minute. If anybody would like to share, feel free. I think there is a Q&A asking if the slides will be made available. Yes, we can certainly make the slides available for you. All right, so hopefully everybody's had time to answer that poll. Oh, someone asked what the red and blue outgoing ticks from the soil meant in the schematic earlier. That was just indicating the rates of evaporation and the moisture moving away from the soil. So, and the red indicates warmer conditions and the blue indicates cooler. So basically we have more evapotranspiration as we move through. Hope that's full. Hopefully that's clear. All right, so let's move on. So I talked kind of conceptually around flash droughts. And now I want to talk about, well, okay, I showed you that conceptual diagram of how things work, but let's think about what they actually look like, right? You know, we can kind of have this theory about, you know, okay, we have these conditions set in, but what causes those conditions? And so this is part of a work, as I said, that we did in that Parker reference, which we can certainly make available to you at the end of the meeting. That's no problem. To think about what flash droughts look like. And as I said, this was a case study in Western Victoria in September, October of 2015. So just to set the scene, 2015 was actually the last big El Nino we had. There was a little bit of drying in winter across much of Eastern Australia, but it wasn't as bad as we had thought it could be, which was a good thing. And as we moved into the end of August, at least in Victoria, in the area that we were focusing on here, there was actually some decent rain. So towards the end of August and into September, there was a decent amount of rain in the first week of September. And soil moisture kind of was a little bit dry, but it wasn't anything to write home about. And so what I'm showing you in this image here, there's kind of two sets of panels, as you'll see. So the first one on the left here, basically, if you look at the colors, they show temperatures. And on the right, the brown colors, basically, the more brown, the clearer the skies. That's how you can think of it. The more yellow and lighter cream colors, the cloudier it is. Think about it that way. There's also other information on the plots that I won't go into because it makes it a bit complicated. Excuse me, but what I want to show you here is that each of these panels, you'll see a date up the top. So basically going from left to right and then down, you see this moves week by week. So this is the week starting the 1st of September in the top left, top right, the 8th of September, next row 15th, 22nd, etc., etc. And that's the same on the left and the right panels. But what I want to show you here is that we kind of moved from a period where, as I said, we had some rain, things were okay, temperatures were a little lower than normal in this first week of September. And as we moved into mid-September, though, a particular type of weather system set in that basically led to very clear skies. It was a dry air mass, so there were very low humidities at the surface. And consequently, we also had heat wave-like conditions set in. So that's what these very red colors on the left side of the plot, I hope you can see my mouse there, but on the left side of the plot were around late September and early October. We actually had conditions that were kind of 5 degrees above average or more for those weeks. And basically things got very hot, very clear. So there was a lot of solar radiation at the surface and very low humidity. And all those things combined to increase evaporation significantly. And the landscape started drying out very quickly. And what that shows you here is basically where there's a little X on the maps here. That's where we had soil moisture that moved into very dry conditions. So below what we call the 20th percentile, in other words, the lowest 20% on record. So you can see that over the course of just a few weeks, even 2 or 3 weeks, we moved from conditions that were near normal into very dry over a very short period of time. And you can see on the right here that the panels at the bottom show very brown colors, which indicates very clear skies associated with that. And so in other words, the causes of this flash drought and this very period of very rapid drying were twofold. They were the fact that we had very low precipitation, very little precipitation, but that we also had a really enhanced what we call evaporative demand. Okay, so in other words, there was a lot of energy in the climate system that allowed effectively soil moisture to be evaporated from the surface quite quickly. And so the consequence of that is that we have a very rapid depletion of soil moisture. So basically thinking about these transitions during drought from wet or very wet to dry, when we're thinking about them, this is part of a broader project that I just wanted to tell you about within the NESP. So this is part of the Extreme Climate Dry, Wet, Hot and Dry program. And we also have researchers in this program who are working on things such as typologies of drought and thinking about the times and spatial scales of drought. We have people looking at the impacts of drought and things like that. And so the questions that my team is asking as part of this project is around how rapidly we can transition from kind of normal or even wet conditions into drought conditions. So let's take a step back again for a second. I've kind of I started off talking about 2022, 2023, and then I started talking a bit more conceptually about the concept of rapid drying and flash drought. But now I want to come back to 2023 again, because this year's been a really interesting year. As I said, we came off the back of the La Niñas last year, and the last few years, I should say. We came off the back of very, very wet conditions. And this time last year, we were very wet. And now, as you know, we're in a drought. But the question is, how do we transition into that? And I'm going to talk in a minute about 2023 and rapid drying in 2023 specifically, because you think, well, it's been a year, right? It's taken a long time to get to this point. But I suppose what I'm going to show you is that it's not necessarily dynamic. But it's not necessarily this linear drying. But before I do that, I'd really love to hear from practitioners in the audience around 2023 and what you've experienced so far. Have you observed rapid drying in the landscape where you are or where you work? And if you have, what have you seen? And what does that mean for your organization? So I'm going to give you an opportunity to fill out another poll now, which you should see on your screen. And I'll give you a couple of minutes to do that. And then we'll come back in just a minute. While we're waiting, I might answer a couple of questions. So is the soil moisture data from Aura-L? Yes, it is. And Anna has asked if there's been any studies looking at the flash droughts from the perspective of stream flow. No, there hasn't, but this is definitely something we would like to work on. We tried to recruit a student this year to look at that, but unfortunately we weren't successful. So yes, that is definitely something we're thinking about as well. And good question from Julia about a relationship between the onset speed and transition out of drought. That is a good question. I said before, typically flash droughts are flashy. They last from about 40 to 60 days, but they can last longer. So at the moment, it's a bit unclear, but again, that's something we would, great question, and we'd love to work on that a bit more during the NESP. All right, so hopefully that's been enough time for you to answer that question. We will move on now, and we'll come back to talking about 2022 to 2023. So 2022, October, November, to set the scene, I'm sure you're all very well aware, particularly in Eastern Australia, of how wet it was this time last year. So again, this shows just this root zone soil moisture. So this is the top, the water availability in the top 1 meter of soil. And it shows it. So the top 3 panels go from October, November, December 2022 to January, February, March in the bottom panel of 2023. So this is month by month. So what you can see, and I just want you to concentrate on this area where there's the magenta box. So this is kind of the area where things got quite interesting at the end of October through to December 2023. And what you can see here is this transition, this drying out, where we go from the blue colors, which are kind of wetter, to the red colors, or the white colors are normal, and then into the red colors. And you can see that happens kind of over the course of a short period of time. So we go from quite wet in November 22, December 2022 monthly average was about normal, and then January was getting into the below average, into the dry side of things. So one might argue that that was actually quite rapid drying. And if you actually drill down into smaller catchments and things in these areas, you do see quite rapid drying. And I'll show you an example of that in a second. But the question here is, we've kind of come off the wet conditions into dry conditions, and things started drying out quickly. So the end, I suppose, of that wet period did happen quite quickly in this region. And now I'm going to show you a snapshot from the Macquarie Bogan catchment. So this is in New South Wales. You can see this is kind of central north New South Wales. And there's a reason I'm showing you this catchment, and that will become clear in the next slide. But for now, just take it that this is a snapshot of a particular catchment in this area. Compared to the magenta box that I showed you here before, it's down kind of in the southern part of that area. And so what I'm showing you here is an average across this catchment, and this is just a time slice. So along the horizontal axis, we've got time, and along the vertical axis, we've got various things that we're looking at here. So on the top plot here, we've got something called the standardized evaporative stress ratio. All that means is it's a ratio between actual evaporation and basically evaporative demand or potential evaporation. So ignoring exactly what that means for a second, all it means is that as we go more negative, we've got a period of rapid change in evaporative demand. Basically, we've got enhanced evaporation through that period, okay? So you can see that if you look down the bottom here, this is kind of thinking about the end of November. So this is around kind of the 25th, 26th of November. We transition from this period of kind of seemingly wetter conditions, and we have this rapid transition into drier periods that lasts around a month. The bottoming out of this change in the standardized evaporative stress ratio ends around Christmas Day-ish, okay? And likewise, you can see this reflected in the root zone soil moisture on the bottom plot here. So here you can see root zone soil moisture that is basically, kind of normal conditions, you would say, somewhere between the 40th and 60th percentile or above prior to the end of November. And then you see this period at the same time as changes in this evaporative demand, where all of a sudden we slide into this period of time where we have root zone soil moisture or soil moisture being very dry. And so this bottom dashed line here shows the 20th percentile, which again is the lowest 20% on record. And you can see that hangs about for a while and doesn't change much throughout the remainder of the summer. So again, this is kind of the end of December about here into March. So why am I showing you this? Why am I showing you this with respect to the Macquarie Bogan catchment? I'm showing you this because as we moved into the end of January and into February, fires started popping up in the region. Now, this is not uncommon during summer, but we had just come off the back just a couple of months earlier of some of the wettest conditions on record in and around, this area. Now, these fires were certainly not on the scale as what we're seeing in Queensland right now, but they were big. They did burn several thousand hectares, and there was loss of infrastructure, including a few residential properties as well. And so, thankfully, these fires were put out by some rain that happened. I think it was March and early April, and so that kind of put an end to that drying. But I suppose the point of what I'm showing you here is that this year, even though we may not have kind of considered it at the time, this year started with a period of very rapid drying. And that rapid drying resulted in some impacts on the ground. And of course, as we moved further into 2023, the developing El Niño and positive Indian Ocean dipole, we dried out further. So as I said, there were some rains around the area. This is just the Macquarie Bogan catchment, which is around here in April. And broadly speaking, across Eastern Australia, it was not bad in the autumn. So what these plots here show you is something called the Australian Combined Drought Indicator. Now, this is from the North Australian Climate Program. If you just Google North Australian Climate Program, they have this drought indicator. It's a combination of rainfall, evaporation, soil moisture. It combines all those things into this indicator that gives you an idea of where we are in terms of drought from those specific things that go into it. Again, not a drought declaration, but just a climatological perspective of drought, I suppose you could say. So what you need to know about this indicator is that if it's blue, it means we've got wetter than normal conditions. If it's yellow to brown, we've got drier than normal conditions. And of course, the more brown we go, we get into what they're terming moderate, severe, extreme, and exceptional drought. So those dark colors indicate drought. So you can see May wasn't too bad. May was kind of maybe normal, perhaps a little bit dry in some locations, but it wasn't too bad. So we came out of that period of rapid drying from the summer and had a little bit of recovery. But then, of course, as the winter moved on, things started to dry out a little bit, particularly along the east coast of Australia. I'm not showing you every month here just because it was too much to look at. But of course, then we hit September. And you can see that pretty much the whole southern half of Australia is in either in dry conditions or very, very dry conditions, according to this combined drought indicator. And I suspect for those of you who work in these regions, that's probably what you're seeing on the ground as well. Now, we haven't looked into this in any huge amount of detail yet, but it does seem from the preliminary data that we've looked at that there was an acceleration of drying in September. So rather than rapid drying from wet to dry conditions, this seems to be one of those intensifications which within a period that was perhaps already a little bit dry, but that accelerated rapidly in through September and October across Eastern Australia. There is one exception, which I'll talk about in just a second. But of course, I'm sure you are all very well aware of what's happening in Queensland at the moment and the significant fires that are there. And that, again, has followed this period of rapid intensification of drying across the east of the country. And these red dots just indicate where there were major fires a few days ago, which I know have flared up further. Excuse me. And unfortunately, it doesn't look like there's going to be any relief anytime soon. So I talked about that one exception. What was that one exception? Well, this is also something that we're very interested in, and this is something that I'm calling here a drought disruptor, right? So for those of you who might be from Victoria, particularly southern Victoria, you might be well aware that the trends, particularly in East Gippsland, so the east part of Victoria, were following very much what the rest of the eastern half of the country, or indeed southern half of the country, was doing up until this point. So September saw this kind of rapid acceleration and drying of the land surface. Excuse me. And there were fires. There were early season fires, which are quite unusual this far south, all through parts of Gippsland. And then on the 3rd and 4th of October, we had this very significant cold front event and rain event come through that dropped 100 mils of rainfall in a lot of locations. There were some where it dropped over 200 mils of rainfall. And all of a sudden, into October, if you average soil moisture from, this is again the aura data for those who know that data set, we went back to kind of normal conditions throughout much of Eastern Victoria. So this basically disrupted that drying trend and has meant that at least in this small location, at least for a short period of time, it's not following the trend of the rest of the country, and they've had a bit of respite. But again, a key question for us at the moment is, how long do these disruptions last for? How quickly, again, can the landscape dry out? And so this plot is just very preliminary data, so please do take it with a grain of salt. This is ongoing work at the moment. This has not been published, but my colleague Pallavi is currently looking at this and is looking at these rapid transitions. And so what this plot shows is what we're calling near normal conditions. So for those who are from a more technical background, that's anything above the 40th percentile of soil moisture, to very dry conditions, which we're talking below the 20th percentile. We're asking the question, how long does that take? How long does that take to dry out? And so that's what's shown on this plot here. And basically, the browner it is, the quicker that can happen, according to this. Now, this is those rapid transitions, right? This is not normal conditions. This is kind of the most, the 10% most rapid transitions between those two values that you can have. And so what it shows, though, is that there are large parts of the country, particularly kind of west of the ranges in the east, all of southwest Western Australia, and parts up top in the north of Australia, where you can really have these rapid drying transitions over the course of kind of 2 to 3 weeks. It's a little bit better along the coast in southeastern Australia. You know, it might take more like 3 weeks there, but the point is it's still a short period of time. So my point here is that even though we can have these disruptions, and I shouldn't say this is normal, you'd have to have a particular set of meteorological conditions and weather systems kind of set back in to promote this drying. But the point is that these transitions can happen rapidly again, even though you get that relief. Again, not saying that that has happened this time, though, just to be clear. And so what I've presented here is really kind of setting the scene in the context for the broader questions we're asking right now as part of the Climate Systems Hub, and particularly as part of that Project 2.8, which I spoke about. So we're really asking questions around what the life cycle is for periods of rapid drying and any associated flash drought that might happen, and how this varies across Australia. And so one of the things we're focusing on at the moment is kind of identifying flash drought or rapid drying hotspots, right? There seem to be places where it happens more than other places. Another question is around the meteorological conditions that lead to the periods of rapid drying. These seem to link to periods of extreme heat as well. So we would like to look at the connection there, because that's really about what we call in climate science circles a compound event. And a compound event is where you get those multiple extremes happening at the one time, which can kind of have an amplifying effect of any impacts on the ground. The third question we're asking is around flash droughts and rapid intensification of droughts. Have they been changing? Have they been changing as we've observed them? And the final one is around trying to quantify these connections between flash droughts and rapid intensification and bushfires as well. As I showed, there was kind of, you know, there's a lot of anecdotal evidence anyway that suggests there's a connection between the two. And of course, the big elephant in the room is also how climate change will affect rapid drying and flash drought, which is another question probably won't get to next year, but hopefully the year after. And so finally, just to ask you questions again and get some feedback from all of you, it would be really good to know what types of information about rapid drying, about flash drought would be useful for you. Is this useful information for you? Do you want to know more about this? You know, what do you want to know? So I think there's some poll up at the moment. If you can just even provide some keywords, that would be really, really useful. And I'll let you answer those questions now. Okay, hopefully that's enough time to just have jotted in some keywords, and we'll finish off now. So the key takeaways that I'd love you to take from this talk are really around the fact that drying as a landscape, drought development, etc., is very dynamic. Excuse me. Our research at the moment is indicating that very dry conditions can emerge just after a few weeks with the favourable meteorological conditions. And that's a really important part of this, is that you've got to have the right atmospheric conditions for this to happen. You don't get that rapid drying without that. In 2023, as a climate scientist, this 2023 year is very interesting for me, this transitioning. And someone, I think someone in the questions mentioned whiplash before. Yeah, you get this climate whiplash between the wet and the dry. And so this post-La Niña drying, particularly in southeast Queensland, northeastern New South Wales, that area that's really being affected by quite dry conditions at the moment. I suppose what we're seeing is that this drying really began back in December last year. After we had kind of the wettest part of those wet conditions. And at least very preliminary data at the moment is suggesting that there was this recent intensification in September, October. So we would like to look into that further. Flash drought, rapid drying, intensification, as we said, anecdotally is often coincidence with bushfires, but we've not had a chance to really quantify that yet. And that's something we'd like to do. And something that I'm also working on the side here is around this disruption of drying, the unlikely weather events that can halt it. But then the question is, how rapidly can we or do we transition back into that dry regime if we do? Oops, here we go. Okay, so just some opportunities for everybody here. We would love for you to provide feedback on what we're looking at, and particularly in the context of what's useful for you. Those who are working on the ground and dealing with drought impacts and impacts of this drying, we'd really love to hear what would be useful for you. And in that sense, working with the NESP Climate Systems Hub knowledge brokers like Ramona, and there's also a whole bunch of state knowledge brokers, as this research ramps up, we'd really love to get feedback from you on that. In particular with 2023, we think it's an interesting case study, but we'd love to hear about it from your perspective. And I know some of you have already provided feedback on that through the poll, which is fantastic. But if there's anything you've missed, please do get in contact. And finally, as I said, there's a lot of work that we want to do, and we would love more people to do it. We're currently searching for PhD students to work on some of these questions, particularly around drought and bushfires. So if anybody would like to think about doing a PhD and getting directly involved, please do get in contact as well. Okay. Oh, there we go. Sorry, one slide I've missed too. And I just wanted to take an opportunity to quickly spruik this as well. This is the Australian Drought Symposium that's going to be co-hosted by the Centre of Excellence for Climate Extremes and the National Environmental Science Program on Wednesday, the 6th of March in Canberra. And basically, we're bringing together Australia's leading climate scientists and drought experts to talk about drought now and in the future. So please do earmark that in your diaries and you will hear more about that soon. Otherwise, that's it from me. Thank you. And I'll leave it there. I think I'll pass back to Ramona. Thank you very much.
Thanks so much, Ailie. That was a great presentation. Yeah, really exciting research that you're doing. And I'm sure, given by, the amount of people that have come today, we've got 150 people online. We've had a great response to the pop-up questions that we've had. So we are really keen to keep working with this group of people to really shape the research, as you said, Ailie, and I think it'll be great. So time for Q&A now. So we have a lot already listed. If you wanted to, I think it's okay, Tani, if they wanted to unmute, you can just unmute your, perhaps put your hand up. Yeah.
I was going to say maybe yeah, put hands up. I can also start by answering a couple of these questions in the Q&A. Does that sound like a reasonable way forward?
Yeah, I think that's probably
okay,
right
great.
way.
So there's definitely a couple of questions that are related here. Someone asked about drying after wet, and then someone else asked why Central Australia doesn't see so much flash drying. I think those two are related, actually. So I think the answer to the question about Central Australia not seeing so much flash drying is largely, like you say, because it's already dry. And so, it kind of doesn't mean as much in those areas, because you're not going from, normal conditions are already very dry. And so it takes a lot of energy to suck the remaining water out of the soil. So I think that's absolutely it. And in terms of going from high to lower rainfall, I think, that's a really good question. And that's something that I would like to see. We don't tend to see Yeah, it's I mean, you certainly have more water available. So if evaporative demand is very high, you will get rapid drying, because if you've got more water availability, naturally it will happen quicker. But yeah, that's certainly something that we'd like to look into further as well. There's a question about predictive aspects to your work. Yeah, that's a really good question, Angela. I think the answer is probably, and that is because of the types of meteorological systems that cause this period of rapid drying. Our hunch is, and what we're kind of looking at right now, is whether they're related to the same types of systems that tend to set in and cause warm spells or heat waves. And if they are, there's been some work demonstrated over the last few years that there is predictability of those on kind of multi-week timescales. So if they're related to the same systems, that's actually really good news, at least on multi-week timescales with respect to prediction. But that's a big watch this space. But yeah, it's at least promising. So maybe we'll flip to, has anybody got any questions with hands up? I actually can't see people, so I'm not sure if others can.
No, Ailie, no one had to put their hands up, and we have a lot in here. So
yeah.
I think, thank you everyone for all your questions. I think there's a question here about climate whiplash. Was that?
Yeah, sorry, I'm just trying to find. There's a lot of questions, so I'm just trying to.
I can read them out. Yeah, or
no, that's okay. I think I saw that too.
Yeah. So I think they were asking, is climate whiplash literature similar to the hot and dry wet transition that you discussed?
Yeah, so I think the climate whiplash literature that you're referring to is really talking about that, wet to dry, dry to wet kind of El Niño, La Niña type of thing. So yes, largely we are talking about similar transitions, but here we're talking about, when we think about climate whiplash, often it's kind of a year-to-year thing, whereas here we're talking about very rapid transitions in a very specific way. So that's, I think that's a little more detailed, I suppose. So thank you for that. I think I've answered the question about rapid and higher.
Mm-hmm. There's also a question here, Ailie, about, so it's from our hub leader, Simon Marsland. So it would be good to answer that one, I think. What is your take on drought that commences in a very flashy way but continues on to become a seasonal or longer drought?
Yeah, it's a good question, Simon. I think our paper from a couple of years ago certainly showed that could happen in the context that we looked at. Certainly the vast majority of these periods of rapid drying, at least as we defined everything, lasted, I think that the average was around 40 to 60 days, depending on where you looked. But there certainly were examples where it went on to last for 3 or 6 months. That was very clear. But the question is, what proportion of what? It was certainly fewer of them that went on to do that. But it's a good question, because I think, if there was no respite in between, that would be a big problem. And I mean, this year at least, we saw very rapid drying at the start of the year. But then in April and May, there was a bit of rain and it wasn't too bad. And when I say we saw, I'm talking about that eastern part of Australia that's experiencing a lot of drought, a lot of very dry conditions now. So they had a little bit of respite, but I suppose it's really down to kind of what weather systems kick in. And you can kind of think about the transition between seasons as well. I think a part of this is that flash droughts do tend to be, and very rapid drying do tend to be, as you might expect, more prevalent in spring and summer, right? So if you've got one that starts in spring or summer, then you've got a much more a much higher likelihood that that won't continue because you'll have, well, if you're in the southern half of the country, that won't continue because you'll have your winter, you know, weather systems kind of come in and hopefully start to erode that. But I know some of the ones, in fact, now that I'm thinking about it, some of the ones that started more in winter and autumn, I think they were the ones that lasted a bit longer. So yeah, certainly something we'll need to look into in more detail, but great question.
Thank you. There's still a lot of questions here. I don't think we'll get to them all.
No, that's
Ailie,
okay.
But
I've just noticed one that's just popped up in front of me that I thought, oh, this is a good question. So is the drying materially different to similar conditions we may have seen in, for example, in the 80s? You know, is this phenomena? Look, Richard, I think the reality is that yes, flash droughts have always been with us, right? You can get periods, like droughts are dynamic, right? You can get periods of you know, rapid drying. You can get periods where it dries a lot more slowly, of course. However, there is increasing evidence, particularly coming in from overseas, that I'm going to say droughts are becoming flashier. So there was a recent paper, I think in Science just a couple of months ago, that basically looked at kind of periods of drying and periods of drought and looked at how quickly that was happening. And basically the proportion of those that were happening quickly to the proportion that were happening more slowly was increasing across the globe. Now that was one paper. It wasn't, you know, it's not a big consensus of evidence yet, but certainly it is, yeah, it's something that we want to keep an eye on.
Great.
Yeah.
Thank you. I think, thanks, Ailie. I think we're come to time. So as there's some really fantastic questions in there. We'll do our best, like we said, to keep in touch with you and try to answer the questions.
That's
so
right.
I'd just like to take this opportunity to say thank you very much, Ailie, for a fantastic presentation, and to everyone in the audience for their great participation and engagement. This has been great. I wanted to, so I'll thank you all for supporting the Climate Systems Hub. We really hope that you've got some good information and you've learnt something today and you've made connections. There are, like I said, I know you can't see each other, but there are lots of you online that are similar. So we will try to bring this group and keep working with you all to help us shape the research for this extreme climate, wet, hot and dry research going forward. There's many activities lined up. So as you can see, it'd be great if you could register for more information. There's a link on the slide to register for the Hub newsletter, and Charney's also putting it in the chat so you could see and spread the word. If other people, you can send the recording on, because we will have this recording up online as well. So where we'll be letting you know about the webinars and workshops for next year. So again, if you sign up or if you email us, we can get in touch. And yeah, before we finish, I'd just like to say that, you know, we really, really value your feedback, and we'll send a short survey at the end for evaluation. So again, please let us know how we can improve these webinars for you and how you found it today. But yeah, I think thank you very much, everyone, and I hope you enjoy your day. And yeah, thanks again, Ailie, and for the people behind the scenes, thanks very much for today. Thanks.